Concrete slump test or slump cone test is to determine the workability or consistency of concrete mix prepared at the laboratory or the construction site during the progress of the work. Concrete slump test is carried out from batch to batch to check the uniform quality of concrete during construction. The slump test is the most simple workability test for concrete, involves low cost and provides immediate results. Due to this fact, it has been widely used for workability tests since 1922. The slump is carried out as per procedures mentioned in ASTM C-143 in the United States, IS 1199-1959 in India and N 12352 in Europe. Generally, concrete slump value is used to find the workability, which indicates water-cement ratio, but there are various factors including properties of materials, mixing methods, dosage, admixtures etc. also affect the concrete slump value. Let's discuss about the factors which influence the concrete slump test. One is material properties like chemistry, fineness, particle size distribution, moisture content and temperature of cementitious materials. Size, texture, combined grading, cleanliness and moisture content of the aggregates. 2 is chemical admixtures dosage, type, combination, interaction, sequence of addition and its effectiveness. 3 is air content of concrete. 4 is concrete batching, mixing and transporting methods and equipment. 5 is temperature of the concrete. 6 is sampling of concrete, slump testing technique and the condition of test equipment. 7 is the amount of free water in the concrete, and 8 is time since mixing of concrete at the time of testing. Equipments required for concrete slump test. Mold for slump test: slump cone, non-porous base plate, measuring scale, tamping rod. The mold for the test is in the form of the frustum of a cone having height 30 cm, bottom diameter 20 cm and top diameter 10 cm. The tamping rod is of steel 16 mm diameter and 60 cm long and rounded at one end. Sampling of materials for slump test. A concrete mix, M15 or other, by weight with suitable water-cement ratio is prepaid in the laboratory similar to that explained in 5.9 and required for casting 6 cubes after conducting slump test. Procedure for concrete slump cone test. First, clean the internal surface of the mold and apply oil. Then place the mold on a smooth horizontal non-porous base plate. Then fill the mold with the prepared concrete mix in 4 approximately equal layers. After that, tamp each layer with 25 strokes of the rounded end of the tamping rod in a uniform manner over the cross-section of the mold. For the subsequent layers, the tamping should penetrate into the underlying layer. Then remove the excess concrete and level the surface with a trowel. After that, clean away the mortar or water leaked out between the mold and the base plate. Next, raise the mold from the concrete immediately and slowly in vertical direction. Finally, measure the slump as the difference between the height of the mold and that of height point of the specimen being tested. Please note that the above operation should be carried out at a place free from vibrations or shock and within a period of 2 minutes after sampling. The slump or vertical settlement measured shall be recorded in terms of millimeters of subsidence of the specimen during the test. True slump is a term used here. True slump is the only slump that can be measured in the test. The measurement is taken between the top of the cone and the top of the concrete after the cone has been removed. Zero slump is another term used here. Zero slump is the indication of very low water-cement ratio, which results in dry mixes. These type of concrete is generally used for road construction. Collapsed slump is an indication that the water-cement ratio is too high, such as concrete mix is too wet or it is a high workability mix, for which a slump test is not appropriate. Shear slump indicates that the result is incomplete, and concrete to be retested.